The Michigan Scientific Wheel Load Transducer System is a 6-axis transducer that measures force and moment loads on a vehicle wheel. Integration between amplifier, transducer, and interface make quick setup and accurate measurements possible. The system can measure longitudinal force, lateral force, vertical force, camber moment, wheel torque, and steer torque. In addition to the wheel loads, wheel speed and position are also measured. Manufacturing, assembly, and calibration are all done at our facilities. All of the mechanical and electronic components are designed and assembled in-house. The transducer is machined out of high-grade stainless steel at our machine shop. The transducer goes through several automated machining processes to produce a high-quality precision transducer blank. After machining, this transducer blank has strain gauge elements bonded to the steel at specific location. These sensing elements allow the forces and moments to be measured independently. The electronics in the wheel load system are also designed and assembled at Michigan Scientific. Ruggedized high-grade components are used in all the system's electronics. The transducer amplifier uses O-ring seal to ensure full weatherproofing. The amplifier and transducer work together as a matched set. Each amplifier is programmed for a specific transducer. We factory calibrate the system using specialized fixtures. This allows all 6 forces and moments to be calculated independently. A unique calibration profile is compiled and programmed into the system, allowing us to virtually eliminate cross-axis sensitivity. After the calibration, further testing is done to ensure stability and performance. The wheel load system is mounted and run up to speed on our Dynamics test machine. The test machine itself is outfitted with precision reference transducers, thus allowing for further validation. After factory calibration and testing, the wheel load system is now ready for installation and use. The complete system is made up of the following components: a wheel adapter, a hub adapter, the transducer, the amplifier and slip ring, a signal cable, a slip ring restraint, an interface box, and finally the signal breakouts and power cables. To assemble the system, the transducer is first bolted to the hub adapter. The bolts are installed loosely at this stage and will be tightened later. Next, the hub and transducer are bolted onto the tire adapter. Now all the bolts can be tightened with a torque wrench. This sub-assembly is now installed onto the vehicle's hub. Next, the amplifier and slip ring are bolted on. This also makes the electrical connection between the transducer and amplifier. A signal cable is then attached to the slip ring. A magnetic restraining bracket is placed on the fender. A lightweight aluminum guide rod is then fastened to the slip ring and placed through the restraint. This restraint allows for vertical motion while preventing the slip ring stator from rotating. Michigan Scientific also offers an optional custom slip ring restraint. A custom restraint can be designed and fitted to secure the slip ring to the vehicle's steering knuckle. Next, in the assembly, the signal cable end is attached to the interface unit. Then a power cable is fastened. Power can be provided by a vehicle battery through a cigarette lighter plug. For this demonstration, a portable power supply is used. And finally, the signal outputs are connected to a data recorder. The signals are put out as independent channels at plus and minus 10 volts analog voltages. The final steps of shunt calibration and zeroing are ready to be performed. Shunt calibration scales the output voltages to the transducer's factory calibration. Shunt calibration is done simply by pressing a button. After several seconds, the shunt calibration is completed and ready for a system zero. A system zero can be performed with a vehicle moving or by hand while hoisted in the air. After 2 revolutions, the system is now zeroed and ready for use. Coordinate transformation from the rotating coordinate transducer system to a fixed vehicle coordinate system is computed and output by the interface electronics in real time. The wheel load system is now ready to monitor and record forces, moments, wheel speed, and position accurately and in real time. In addition to passenger vehicles, Michigan Scientific also offers other packages to accommodate sizes ranging from heavy-duty dual wheels to smaller vehicles such as a motorcycle or ATV. We also offer a wireless telemetry-based system which eliminates the need for a slip ring.